Students, from here we are starting alternating current. Previously we studied direct current, which we call it as DC, and the current which now we are going to study, its short name is AC. I have told you previously also what is the broad meaning of AC. It is alternating current. Alternating means which is changing with time. And the changes with the time can be of any type. You can see the relation of the voltage with the time can be like this. It is also alternating. It is also alternating. Also this one is alternating. But nowadays a universal standard is built up, and according to that AC is basically a sinusoidal current, or say simple harmonically varying currents. So it became our standard. This is the meaning of the alternating current. But nowadays the universally accepted term is, the word is AC. By AC we mean in short that it is a sinusoidal current. Sinusoidal means which varies like the sine or the cos functions. And in short we can say simple harmonically varying voltages or current. So AC voltage, AC current will be using the terms in this way. This means that they are simple harmonically varying, or say simple harmonically time dependent voltages. See how we denote it in short. V is equals to V naught. As we denote the simple harmonic motion, A is A naught sine omega t. In the same way we define the alternating voltages here. V is V naught sine omega t. And V is equals to V naught cos omega t. Because both the functions are simple harmonic, they are harmonic functions. Simple harmonic means we know single function, single sine or single cos function, because with their combination many types of harmonic functions can be produced. In the same way we write the current I is equals to I naught sine omega t, etc. So by alternating current we understood this. And second thing, the meaning of the PD, which we write again and again, potential difference between two points. In short nowadays it is called as voltage. Voltage means that the potential difference between 2 points. Alternating voltage means the potential difference across 2 points. So whenever we talk about the voltage, what is the voltage? It is 220 volt. What is the voltage? It is 100. So voltage is 100. That means the terminal potential difference is that particular voltage. So we'll be seeing that also, how we have the alternating circuits. Voltage amplitude. So if we are having an AC voltage, let us take an AC voltage. AC voltage is V is equals to V naught sine omega t. So when you will be plotting its graph, so how it will be? When you will be plotting the graph, it will be a sinusoidal function, and so on. This is the time and this is the voltage. Maximum value of the voltage, as you have studied the graph very well. We have studied this in the simple harmonic motion also, and also we studied in the trigonometry. So the maximum value of the function is V naught. So voltage amplitude, V naught is the amplitude of the voltage, or say voltage amplitude. That is the maximum value of the voltage at some instant. And sine omega t, its maximum value is 1, minimum value is -1. So in the same way voltage will be in between -2 plus V naught And plus minus means this, that the direction is changing again and again. In the positive direction, potential difference increases, then it decreases, becomes 0, and then it increases in the negative direction. The terminal which was at higher potential initially now will come at the lower potential, and so on. So that is denoted in this manner. The source of the AC voltage is denoted in this manner. This is the AC voltage source. The symbol is like this. Sometimes this is positive, this is negative, sometimes this one plus and this one negative. So in this way, cycle wise, it keeps on changing. How this voltage is generated, we'll be seeing this. But first of all, let us see what is the angular frequency here. That is the omega. And what is its relation? Angular frequency. Just now we have seen the voltage V is equals to V naught sine omega t. Here what is omega? Omega is the angular frequency. This one is a favorable term. We don't have difficulty to understand it. And omega, how much it is? It is equal to 2 pi n. N is the frequency of AC voltage or current. So here we are having voltage or current. If it is AC, then it is having a frequency equal to n, and 2 pi n is the angular frequency. So when one cycle completes from here to here, in the same way you should know to calculate how many cycles are completed in 1 second. So from here to here, second cycle is completed. The cycles per second is the n, and 2 pi n is the angular frequency. And second thing, what is 1 upon n? 1 upon n is the time t, time period of one cycle, time period of one cycle. So here your time period of one cycle will become t, 1 upon n. So what will be the time from here to here? It will be t. From here to here, what will be the time? T by 2. This is capital T, suppose, and this is the time axis. This is capital T by 2 time point, and similarly this is T by 4 point. So come, let us see few more things. Average value of current or voltage. So come, let us see, suppose we are having a voltage Vt, that is a function of time, which is equal to V naught sine omega t. So we want to find out the average value in a cycle, average value in one cycle, average value in a cycle. So what is the average value? What is the formula for the average value of the function? Formula for the average value of function is in somewhat this way. Suppose we are having the function f. So its average value we denote with the help of these two brackets, this type of two brackets. Time period is 0 to t. So the integration will be from 0 to capital T. In the denominator also integration is there from 0 to t dt, but its integration's value is t, because t is what? From 0 to t dt. So here directly we are writing the t, value of the function from 0 to capital T dt. This is the average value of the function over the time. Average value, average velocity, average speed we have studied. So here we can find the average value for any function. If we have to take it with respect to time, then dt will be taking here. So see what will be happening here. Average value of the voltage is simply integration 0 to t V naught sine omega t dt upon capital T. What will be the integration of the sine omega t? And V naught and t will be constant. So we integrate sine omega t. The integration of the sine is minus cos. And here it will be the integration of sine omega t, it will be minus cos omega t. And omega also comes here in the denominator, like it is a multiplication with the t here, which is constant, it is omega. So we have to divide it by omega. So you should know to integrate properly. I have written directly. Now if we substitute the value, then what will happen? Cos omega t. Now what cos omega t means? Cos omega t means cos